Hello, my name is Christian Dazen. I will give a presentation about relax and recover automated testing. So, who am I? I'm one of the main contributors of relax and recover, and it's the first time in my life that almost nothing had to say about relax and recover. I had other people who were doing that for me, but it's very nice. So, in this talk, so for those who are not aware what relax and recover is, it's a bare metal disaster recovery tool written in Bash, and it's open source, of course. It's perfectly integratable with other backup tools, open source and commercial ones, and it's able to cloning to different kind of methodologies like V2V, P2V, and so on. And it can work with very complex systems and very large enterprise systems. So it's very scalable as well. It is being used in very big companies. One of the companies where I do consultancy almost daily, they have, I think, more than 10,000 Linux systems using REAR. And the nice thing is the disaster recovery image is very flexible as well, in the sense that it can boot from the network, can boot from the ISO, can boot from USB, and even from the RAM. Well, that's more for testing, but okay, it's away. So that was the introduction of REAR, and that's it, in fact, for me. What I want to concentrate in this talk is testing, because REAR is now more than 10 years old, and testing was always a pain because it's so heterogeneous. It can run on, let's say, Linux distributions like Debian, Ubuntu, Red Hat, SUSE, and so on and so on. It can also run on different hardwares. You have ProLines, you have Dells, and everything has different tweaks, and that makes testing very difficult. Above all, because it integrates so fluently with different backup methodologies, testing all of these things is incredibly difficult. Furthermore, as I said, we can boot from different methods. Also that gives an extra layer of testing that should be done. And every time that we make a new release, that's a problem, because it's impossible to test everything. And it will never be possible to test everything. That's why we have a very good user community, and when we bring out something and it breaks, then we know it very quickly. So, the bottom line is, testing is and will always stay a pain. But we try to overcome first levels, that's way of speaking, and get some automated testing done. So it's always finding the right balance between continuous integration, continuous development, and continuous testing. We already have for many, many years, thanks to SUSE and the open build services, that daily effect when REAR snapshots are changed, when we merge something into HitCap, automatically the nightly builds are made and the new RPMs are available. It's already there for many years. So that was the first step. What we do now is every time that there is a new build, we can automatically test it. Of course, we may not forget our contributors. Most of the contributors are here, the active contributors. We have many, many contributors over the last 10 years, but like in many open source projects, they do something and after a while they are gone, because they have other kinds of interest, which is fine. And important to know is, HitKit is our friend, our master code is there, even our website is over there, issues are there, and also the free support is on there, the HitKit issues. And we also have commercial support if required. For big companies, that's something useful. Okay, why did we start with automated testing? Because with customers who have a support contract, they demand quality tests. So that was the first step that we did, is to introduce these automated testing to have at least an improving level of contribution and improving level of stability in our software, that it didn't break, or if it breaks, that we know it in fact immediately that it will break. So what will the automatic testing in fact do? It will create a disaster recovery image, it will create a backup, it will boot and recover virtual machine over PXE network booting, it will recover it automatically, and it will restart. And after the restart, your recover virtual machine is exactly the same as the client. You will see it in the next slide. This is a test configuration. So what do we see here? We have the client, we have the server, and the recover VM. This is all done via Vagrant. And you have the hypervisor on the top. We have two networks, in the DHCP network and in private network. We will be using the private network. We use Vagrant. We need a Linux host system because we could be using a Mac or a Windows, but for the moment I just say Linux. And we need Vagrant, and we need as a hypervisor, you can use Oracle VirtualBox or the libvirt. This system is using libvirt. I have my second PC with me with VirtualBox, and it works equally well. So what are we doing when we say starting the script? We will start up the two VMs, the client and the server. The server is in fact what it is saying. It will contain the backup. It will contain also the PXE boot environment. And the client will just start up, install rear, the latest version of course, start the backup goes to the server. When it is done, it will automatically shut down the client, start up the recover VM, and that starts in fact the recover. It PXE boots from the server and recover the rear completely automatically. When the recovery is completed, it will shut down and reboot, and then it will be able to start up by itself. At least that is the purpose, of course. I already said this. These are the requirements, what we need. So also the automated testing is in simple scripting. It is also available on GitHub. You can see it here. It's on my personal name account. You can see it also on Memback. You just have to clone it and start the script. And you can log in as Vagrant. You can log in as root with the password Vagrant. And that's it. Like I said, you can log in different ways to the VMs. You can use VNC Viewer. You can use the Oracle VirtualBox or the libvirt Virtual Manager GUI, where you can just use Secure Shell or use the Vagrant commands if it is required. This is with the VNC Viewer. I normally use the VNC Viewer with libvirt. With VirtualBox, I use normally the GUI that is delivered by Oracle VirtualBox. Okay, enough talk. Let's do the demo. So here you can see the script. It's a simple script, in fact. It's a sequential script. It has some commands because it is a purpose to test the distribution. The only distribution for the moment implemented is CentOS 7 because that was required by the customer. And we can have boot methods. The default boot method is PXE booting, and the other one that will be supported very soon is ISO. It is support because I also have a workshop using ISO, so it's just a matter of time to implement it over here. It's already half implemented but not complete. The boot server can be changed. By default is the server VM. but if you have another requirement, you can overrule it. The same with the provider. But I will start the script and I can talk afterwards, during the script. Because this is libvirt. The -p is the provider. The default is VirtualBox. Because this is libvirt, I have to say -p libvirt. And that's it. The rest I can keep as default. So start it. What is the script doing now? You can see it on the bottom. It will start up the two VMs, the client VM and the server VM. So this is pure Vagrant work now. Vagrant is starting up the two VMs. I could have cheated and already started them on front, but it is not really quick enough to do its job. So once the two clients are up and running, you will be seeing, hopefully soon. All right, they are provisioned. I don't care to have an update for the moment, so we wait for 5 seconds because you can interrupt. Now you have the status. You have seen the two client and the server VM are running. We do a test if the network is okay. Yes, we can communicate with the client and the server VM. And now, what the client VM, inside the client VM, we will pull the latest rear snapshot image from the OpenSUSE build services. That is what you're seeing now. You see? Hopefully it will be working because I haven't tested this. It is a new one. So this is live, guys. I'm not cheating. It's not a video. This is live, so it can fail. All right. What you see here, over there, that is the etc rear local configuration. So what you see here, that we're using PXE booting. Backup is using tar, and we are using the backup URL is going to the server 15 to the TFP boot area, but under the TFP boot area there will be the server area where to store the backups. And you can see here the PXE recover mode is unattended. That means just continue. If you wonder why here for the kernel command line I use net.ifnames equals 0, that's not required for libvirt, but that is required for VirtualBox. Otherwise it will be using BIOS def names for its network interfaces. And then it will break your automated recovery. Okay, it will now starting the live ISO PXE boot image is made. It's already stored. You can see it here. And now it is busy with the backup. That will take a minute or two, I hope. It's not updating itself very frequently, it says here, but okay, that's not too serious. That takes longer. Backing up takes longer than recovery.
So you're only supporting CentOS 7 because that was the only requirement.
Yes.
But have you tested the same tool with other distributions? Like CentOS 6 should be mostly the same unless we're doing.
I have no doubts that it will not work. It's just a matter of implementing it and putting time in it to test it out.
And now, how old is the automation?
How old?
Yeah, like.
Oh, month or two.
Yeah, so it's okay. So
It's
that's
quite
what I
new.
thought.
It's quite new. Yeah, yeah. Okay. Finally, the client is halting. We will starting up the recover VM. It will try to PXE boot. It will. There are two interfaces: the DHCP interface and there's the private network. It first tries the PHCP interface. That won't work. Then it will try the second interface. This is libvirt. If you use a VirtualBox, you cannot PXE boot from the server VM. You must PXE boot from the host. That's the limitation of VirtualBox, but okay. That's why I said we're using Linux. Okay, that's the menu. It's already starting the RAM image. System is almost up and running, the recover image. It's already formatted to the hard disks, and it's already restoring the data. Within a minute or so, it will be finished. What it will do then, it will trigger the server configuration, the Pixie boot configuration, and says, okay, now you have to boot the next time from the default hard disk, not from the network, not from the RAM image. It's already done with restoring the data. It's rebuilding its initial RAM disk because it was a cloning. It's not exactly the same disk size. So it was a cloning. Eh? This was a V2V migration that we did. So it was not an exact copy. It was an other size of disk. Otherwise we would never rebuild our initial RAM disk if it's not the same. If it was the same. That takes longer than the recovery of the data. Okay. Okay, once this step is done, then we are finished. Just installing the grip, bootloader, and then
that's the step we were referring in the other talk that I was asking about the MBR, and he said that grab is starting. That's the step.
Okay. The 30 seconds, that's normal. If you want to interact and to check something, even that is tunable, but okay. It's still fair, 30 seconds waiting.
Is it easy to exclude some file system from the backup?
Yes, that's all foreseen. Most of these variables, you have to look in the /user/share/rear/conf default.conf file. All the used variables are defined over there with some description. And Johannes is very good in making good descriptions. Long descriptions. And good. Huh? Mine are mostly some comments effect, smaller comments, but Johannes prefers longer comments and longer text effect, and I do agree that it is useful. So. Okay, system is restarting, so the recover VM is now completely restored and rebooted, and we have our prompt. So the latest rear snapshot was okay. You should be able to log in. Password is vagrant. And if we do an IP -A, the password should be 10, which was the client. So we are now exact copy of the client.
And during the automated testing, do you do like any check on the recovered system, like checking if a file is there or whatever?
Yeah, yeah. Oh well, this is not. I have not foreseen this in the talk. Let's see. Wait. I will close this QME, and this will stop. If I do the help again, you will see there is a -T from test directory. The test directory is this here. Oh. These are the tests. They are not from me. They are coming from Red Hat. Red Hat is using these tests to validate rear if they want to update something, and that use beakerlib, and it already works. But probably don't have time to do something. Wait a second. I will stop. I will cheat a bit. I will halt the recover. I will start up the client again, because it's vagrant. Even if the recover is now the client, it would still wanted to check the vagrant client VM. So sorry about that, but okay. Starting up this. Okay, then I go one back. I will use the smallest test, which is a very simple one. It's just the check out the layout of your system. It's something that has been modified. If you update the kernel or you modify or increase one of your volumes, then it's required that you rebuild the VEC and do rear image. All right, so the test directory. So that's the check change disk layout. So rear automated, I have to use the libvirt. And the test, let's use this one. Oops, okay. That's a validation test. So now we can skip the bringing up the vagrant because they are already up and running. So that goes quicker. Voila. It copies in fact the complete test to the client, and it already did the test. So the first test is done, and what I do, I copy the test back to my host system here. So every time I run a test, I also have a copy of the logging. So that was a very quick demo of the tests that are possible. The other test will take much more time because it will also make ISO images, check the ISO images, or even make them backup. But I don't have time for this to demonstrate. This demonstrates what the possibilities are of these test scripts prepared by Red Hat. This is written in Bakelib. But yesterday I learned something new with batch, and I will use that in the future also.
Are these tests available? Like
Yes.
these
Everything is on GitHub.
included the test?
Yeah,
Okay.
yeah. It's made available by Red Hat also. Okay. Are there any questions whatsoever? Was it clear enough? It was a nice talk for me because I didn't have to say too much. System did it for me. A question?
Yeah. Do you have an estimate about how much time you need to bring another operating system? Like,
Okay.
just getting
The question was, do I have an estimation how much time it will take to bring another system distribution effect into the rear automated testing? If it's an RPM base, it's rather quick. If it's, for example, an W1, that will take a bit more time. But I think normally a few days. Yeah, a few days would be enough. Because the methodology is exactly the same as maybe the other packages, and for the rest it's exactly the same. Yeah. The framework is there, so it's only just a matter of making the right moves, in fact. Yeah. Any other questions? No? Then I thank you very much for your time, and please enjoy the rest of the day, here or outside. Thank you.